We are still on composite and the center of gravity of composite bodies. Now we are in the case when they are solid. So here we have now a combination of a cylinder and then a hemisphere. Hemisphere is always a half of a sphere, a full sphere. So we are going to still use this formula. If you want to get a volume of that body times the weight per unit volume, but we always don't know the weight per unit volume. That's why we let it to be W. If you want the center of mass, now you let this be M, as simple as that. Okay, so the center, find the center of gravity of the uniform composite body below, formed by combining the cylindrical and hemispherical solids as shown below, as you can see. So what we do now, because they are solids, we calculate down their volumes. If they are laminar, then we calculate the areas. But here these are volumes because they are solids. So what we do, we call this one, we say that this one is going to be having volume 1, and then this one is going to be having volume 2. So now our volume 1 is going to be pi r squared h, because it's a volume of a cylinder. So our pi is going to be pi into, now the radius from here up here is 6. So the radius is a half of the diameter. So it is going to be 3. So we have 3 squared times the height. Now the height of the cylinder is from here up to here, it is going to be 8. And this is going to give us 9 times, which is 72. As simple as that. Pi meters cubic. So now we need to get the weight. We say, how is weight corresponding? I mean, how is the weight related with the volume? If we get the volume times the weight per unit volume, shall be getting the weight. So our first weight for this first body is going to be now the volume, then times the weight per unit volume, which we said that will be the weight for it per unit volume. So times W, there shall be having our first weight. Then volume 2, now is that it's a sphere, but this is a hemisphere. The volume of the sphere is given by that, but the volume of a hemisphere is given by a half the volume of the sphere, as simple as that. So it's given by 2/3 pi r cubed from here, a half of that. So our volume 2 is going to be 2/3, then pi into r radius, which is 3 cubed. This is 3 cubed. Okay, so this is going to be 27. 27 divided by 2, that's going to be 9. 9 times 2, that will give us 18. So our volume 2 is going to be 18 pi meters cubed. So we are in meters. Okay, so now we get also the weight 2. We shall get the pi, then times what we call that weight per unit volume, which is, we say it's going to be W, as simple as that. Now, that means that this one, this is its weight, and this separate, this is its weight. Now the question is, what is the weight of the total solid? Now we get the total weight. The total weight by summing these two. We sum 72 pi plus 18 pi into W. So that is going to give us 90 pi W. Now this is the total weight for the whole solid. Okay. Now from there, we start now we start this one symmetric at having the line of symmetry. So either you take the line of symmetry to be the basis, or you consider AB and AE to be your line, I mean your axis. It's up to you. No one is restricting you. So we say, let the center of base AB and AE be the axis. Now from here, why am I choosing AE and AB? Because they should be perpendicular. The axis we are choosing they should be perpendicular. So this is perpendicular to this. So that means that now my center of gravity is going to be equal to. Now, when you get the center of gravity, you need only two things. You need the weights and where those weights are acting. So we have the weights. We need where they are acting. So what are we going to do? We are going to use that to get the center, because we know the center of gravity of these two where those two are acting. So we shall use the weight I, xi over yi. Those are the coordinates where that set weight is acting, and the sum of those weights. As simple as that. So if now I want to act now, if this is a cylinder, of course this one is going to be having a line of symmetry as you see there. But because we are going to consider this and this, that's why I'm ignoring it. But some people, after getting the line of symmetry, they put now everything line of symmetry, so they will determine from the line of symmetry. It will be now it will act as their vertical. And if it acts as their horizontal, and if it acts as horizontal, it means everything here, the y coordinates are going to be zeros. From this line, if you consider it, it's up to you. Anyway, because this is a cylinder, its center of gravity is going to act in the middle, so let us say D1. But you said for a cylinder, the center of gravity is h over 2, the height. So, from here up to here, if from here up to here is 8, and this is acting in the middle, so meaning from here up to here is going to be 4, half of this. Then the radius from here up to here, because we are from AB. So from here up to here, so from here up to here, you see we have moved the 3, because this is going to be 3 meters, and this will be 3 meters. So we have 3 there. So which weight is going to act to here? Our weight 1. So the weight of this cylinder, the weight 1. Then when it comes to this one, its center of gravity is always acting there. So let me call it D2. How do we get D2? Now it depends from the base, it's going to be 3 over 8 per 8. 3r over 8, then the radius. So now this distance here, from here, this distance here is going to be 3 over 8 times the radius, which is 3, which will give me 9 over 8. So this distance always 9 over 8 meters. Now remember, I need it from AE. So from AE, I'll add it. You know, from here up to here is 8. Then I add this. So 9 divided by 8 is then plus 8, which is 9.125, comma, from here up to here, from this up to here, from here up to here, it's going to be 3, because it's the line AB. So always you see that if the line of symmetry is the same, it has a line of symmetry, and they can cover each other when you fold it, then the same coordinates are going to be there. Unlike some coordinates, which are having lines of symmetry, but they cannot. They are having some contributing parts. Anyway, so let us say that our center now here, our W2. So now we have the coordinates of this weight from these axes we chose. So our center of gravity, let us call it E, to be there. It's what we are looking for. So the center of gravity is X bar, comma, Y bar. So this is where our weight is going to be. Which weight? When we get a total, the 9 pi that which we are looking for. After getting that, the idea is simple. Put into our formula, X bar, Y bar is going to be equal to 2. When I is 1, we have W1, the coordinates for that first weight. Then we sum coordinates for that second weight. The whole over, you get W1 plus W2. Or you can use a table, as most people are doing. You can also use a table, no problem. So here my X bar, Y bar is going to be our weight 1. This weight 1, we have the coordinates. So this weight 1 is 725W, is acting at 4, 3. Then plus our weight 2 which is 18 pi. Sorry. Did we add it properly? Sorry. So we divide, yeah, I think it's okay there. 9 times 2, yeah. Then our H2 is 18 pi W into, where is this weight acting? It's acting at 9.125, then 3, the y coordinate. The whole over the sum of these two weights, which we saw it's 9, or you can just say 72 pi, then plus 18 pi W. Then after that, you simplify x bar to give this as one thing. Then over this, let me pause as I calculate them. Okay, so my first, when I get this times this plus this times this, I'm getting 452.25 W. Then this one, when I get this times this plus this times this, that is going to give us 270 W. The whole we are dividing with 90 pi W, which you can help separate 2, 4, 5, 2.25 pi W, the whole over 90 pi W. Then this is already 3. Even without calculating, you would have seen that. So by the way you started, we are taking the same axis. You see that always this one is going to be 3. You can also easily, by simply just manipulate the x coordinate, because the y coordinate is always going to be the same there. Anyway, so my x bar, y bar, x bar is, y bar is given, it's 3. Then the other one is going to be 425.25 divided by, for it is 5.025. Therefore, the center of gravity is at 5.025, 3, taking A, B, and A, E as the axis. Because it's going to be different if someone takes other axes. That's why I'm very clear there. As simple as that. So we are now going to combine a cone and then a hemisphere. So see you in the next lesson. But please don't forget to subscribe to the channel.